All right, you're making good progress. Moving right along with assignment 14.1. Let's finish up. It's time to talk about an idea again. So theoretical probability. What we have talked about up until this point is theoretical probability. Theoretical probability, for lack of a better word, is the probability that we think should happen. Alrighty, so like here, the following table is from rolling a 6-sided die 120 times. So we want to determine the theoretical probability and the experimental probability of the following events. Well, theoretical probability is what we should happen. So theoretical probability is going to be like the probability of my event. And so that's going to be the number on the die over the total numbers that are on the die. So like ours would be out of 6 because it's like, what's the probability? For instance, what is the probability that I get a 1? Well, there's one way to get a 1 and there are 6 outcomes. That would be theoretical probability. That's what theoretical probability is. Based on just looking at the object, how many ways can I get what I'm looking for, divided by all the ways that it could happen. Now, experimental probability is a little bit different. So when they want us to find experimental probability is the probability that happens when we actually test it. So this top row is for theoretical probability. I should get a 1 out of 6, a 3 out of 6, a 1 and a 3 out of a 6, a 3 or a 4 out of 6. The frequency says already, I'm going to roll this 6-sided dice 120 times. And every time one of the outcomes comes, one of the faces lands up, I'm going to record how many times it happened. All right, so frequency is for experimental probability. It's how many times we actually rolled that number. So this is saying we rolled the 6-sided dice 120 times. 15 of those rolls were a 1. 18 of those rolls were a 2. 20 were a 3. 17 were a 4. 5 happened 24 times, and 6 happened 26 times. We are going to use that for experimental probability. So what is the probability that I actually roll a 6? So the probability that I roll a 6 is the number of, let me back that up. So theoretically, the probability I rolled the 6 is going to be the number of 6s over the total number on the dice. Well, how many 6s are on a 6-sided dice? There is 1 6. How many different numbers? 6. An experimental probability is going to be, again, the number of 6s over the number of 6s rolled over the total number of rolls. So how many times did we roll a 6? We rolled a 6 26 times. We rolled the dice 120 times. And when I reduce that fraction, it's 13/60ths. So while I love fractions, sometimes they're hard to compare. So theoretically, what should have happened is I should have gotten 0.1. I should have gotten a 6 0.17 of the time. And but what I actually got was 0.22. So I ended up getting 6s way more than expected. Not way more, about 5% more of the time than I expected. All right, so finish the chart listing theoretical and experimental. Experimental, again, is going to be based off of the frequencies on the bottom. Experimental would be just what you would look at with the cards. Now, if you look at the bottom of the page, you're going to use those shapes to answer the questions 25 through 26. Hopefully by now, I'm not going to walk you through those. I want you to give that an honest shot using what you already know about probability. All right, so let's go ahead and finish 14.1 and get those answers into Student View. Hope these videos helped.